Okay. Okay, standard position. Okay, we're paying attention because some of this is new, some of this you did in AP, some of you weren't in AP, so it could be new to you. So standard position is when we sketch angles called rotational angles on the Cartesian plane, the XY axis, with the initial arm where the angle starts as the positive X. We're always going to start on the positive X. If we go using a negative angle, we're going to go clockwise. If we use a positive angle, we go counterclockwise. Okay? These angles can be positive if you move counterclockwise, and negative if you move clockwise. So, let's first draw our little axe. Grab a pen. Left, grab a pen. All right. So, what we're going to first do is we're going to draw ourselves our little axe. Oh, wait. You do that. I'm going to show off the fact that I can do this. Now you can all be jealous. It's totally fine. Right? No one asked you. Okay. So, the first one is a, well, those aren't very good. I'm a little bit angled. I'm sorry. Anyways.
Okay, we're drawing angles.
Okay. True. All right. So, okay. If it's positive rotational angle, listen, we are going to start on the x-axis no matter what, positive or negative. So, we're paying attention, right? We're not going to be lost souls at the table because there's all these lovely desks here that will fit you. Okay. So, I would. Okay, 0, 0. Put a dot in the middle because that's your rotation. Do you remember like in little school when you do like clocks or something like that and they would put a little metal thing in and then you could like spin it around? It's basically this. I'm going to end up giving you guys unit circles so that you can do that as well with an arm on it. Okay? So, this is your initial arm. I'm going to write initial. So it's where you start. If it is counterclockwise, then it's positive, correct? So I'm going to label my arms. I'm going to go 0, bless you, 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360. Now, does it have to stop at 360? No, it could keep going, right? You got 90, and 90, and 90, and 90, and it can go on for life. There's an infinite number of angles. Now, in grade 11, they basically stopped at 360. You know how grade 12 amps everything up? So now we stop at no angles. So we could go to negative infinity, and we can go to positive infinity, and then we can also do it in gradients. Okay? So we just like, hey, 0 to 360, and then it's like, now everywhere! Just in grade 12. That's how everything is. Like, ooh, we do quadratics. Now all the functions. All right. So, say I want to do 120 degrees. We're going to be quiet because I will lose you. So, 120 degrees, I know that I'm going to have to go counterclockwise. We agree? How much past 90? 30 or 60 less than 180, correct? The middle of these are all 45s. Yeah, because it's 90. So we're going to go 30 past it. No one's bringing out a protractor to see if you actually did 30. But if you go like here, you're wrong. Okay? Okay. Now we have to show this other arrow is extremely important because the other arrow actually shows the direction that you're going. If I draw this, this is actually another angle in a negative way as well. It's the exact same spot. So how do we show that it's positive? We show that we're going counterclockwise. So we go from 0 to 120, and we write 120 degrees here. That arrow is extremely important, showing you're going from the initial arm to the terminal arm. Now, negative rotational angles, I would have 0 degrees, negative 90 degrees, negative 180 degrees, negative 270 degrees, negative 360 degrees. Anyone, could you tell me what that same angle is in negative? I want to terminate here. I want to terminate 30 away from here. I want to go like this is my initial. I want to rotate around here, but I want to go this way. Anyone know? What could it be as negative? What did you get? Negative 240. Exactly. These are coterminal. This angle and this angle are coterminal with each other because they terminate on the same arm. They're the exact same answer. Because remember on your unit circle, every single coordinate on your unit circle is linked to an angle. Yeah? So that would end up with the same exact dot on the unit circle. All right? That's why the arm is so important, because it tells you if it's negative or positive. And then I have my negative 240 labeled. Okay? The terminal arm is where the angle ends, should say S, ends, and it can be in any quadrant on any axis. What angles correspond to the axis? We already did that. But we could keep going, right? We could keep drawing more numbers on there. Yes? Right, Levi? Yeah, I know. He's not going to pay any attention. So stop. Okay, go. Sketch these four. Okay. So, and not labeling. Walk around. There's quite a few people, actually. So, remember you have to label. This is positive, so we're going to go 0, 90, 180. Degrees, 270, 360. If you use a different color, it's also a lot easier to see your initial arm, but I know you're using pencil for a reason because I would suggest that as well. So we rotate around here. Here is my initial arm. You need to have that. If you're just drawing a line from nothing, you didn't give yourself an initial arm. You're like, but the x-axis isn't. The x-axis can't be an arm. It's the x-axis. All right. We're quiet, right? 45 is halfway, so we're a little less than half. We arrow to it, and we write 40 degrees. 140. We label, we're 0, 90, 180, 270, 360. We need degree symbols. Degree symbols are more important this year than they ever have been, right, Levi? Of
course.
Watching me? Okay. So, degree symbols are extremely important because if you do not have a degree symbol this year, it is a radian measure, which is not degrees. So the degree symbol, if you don't write it, we assume it's radian. And you can't say like, Mrs. Lepp, you know it's 140 degrees. No, I don't. I know it's 140 radians because you didn't put a degree. Okay? I don't mark your diploma, someone else does. So I want you to get hundreds. So 140 is how much past 90? 50, or it's 40 less than 180, so it's a little less than half over here. Rotates here, initial, draw it, 140 degrees. Okay, negative 240. We still have to label, so please go and check. Remember, you have to do what I do. I'm not doing stuff just because I like extra things. I'm doing stuff so you can get full marks, correct? So make sure your axes are labeled as well. So you have 0, you have negative 90 degrees, you have negative 180 degrees, negative 270 degrees, negative 360. 240 is less than 30, so it's the one we already drew here. And then I put 240, negative. What am I missing? The arrow, because this could be 240 or it could be 120, correct? So we have to make sure that we're showing that it's actually going clockwise. Yeah? It's very important. Okay, 340. We label, we're going counterclockwise because it's positive. We have 0, we have 90, we have 180, we have 270 degrees. Check that you have degree symbols. They're very important. Get used to writing them. If you start writing them, Arlen, right, make sure that you have degree symbols, correct? If you have degree symbols now, you won't forget them when it's extremely important when we start adding radians, okay? So we need 340. It's 20 less than 360. Might be a little shy. That's a little too small. So that's what a lot of people are doing. What am I missing? The initial arm and the 340. So I need to have this. 340. Okay? Flipping over. Okay. Now, we are going to learn how to, this will be really easy for you if you pay attention. So, because you guys understand unit cancellation. If you understand unit cancellation, you don't have to memorize the definitions here. But, what I want you to remember is that a circle, if I do a full circle, this would be 0, this would be 90, This is 180. This is 270. This is 360. You don't have to write this. I'm just explaining why the actual formula works. Because we always have to understand why, correct? If you don't understand why, you find bad marks on tests. Because the diploma questions are very, very, very conceptual and problem solving. 30% of your diploma is procedural. That's those just basic see-do questions. Then you have 70%, which are like, here's the concept, how do you apply it? Or a problem. Okay, so this is in degrees. The reason why you guys like degrees is that's how you've grown up your whole lives in degrees. If you grew up in radians, you'd be like, what the heck's a degree? Right? So what you need to know is 360 degrees is the same as 2 pi radians. So if I went to make myself, if you guys are converting between minutes and seconds, how many seconds are in a minute? 60. So if I went, okay, I have 360 seconds, and I want it in minutes. You would, bless you, you would times by the ratio of seconds and minutes, correct? So you'd say, okay, 60 seconds is 1 minute. I want the seconds to go away, the seconds unit to go away. So would I go 60 seconds over 1 minute as my ratio? Or would I go 1 minute over 60 seconds? Why? So the cancels of the seconds happen. So we get 60 seconds, we get 1 minute, the units cancel, which is our goal. Then we're left with minutes, correct? 360 divided by 60 is 60, and then we're left with the unit minutes, right? We have done this before. You guys would have done this. 360 divided by 60, 36 divided by 6, 6. Yep, I was just doing that in my head as I was staring at Cora. Because this cancels this, and 36 divided by 6 is 6. Yeah. Yes. Okay. So the whole point in this is if you want units to cancel, whatever you have, the conversion has to have that unit on the bottom so that they cancel. We agree? Okay. So with radians, I'm back here, sorry. I have 360 degrees is the same as 2 pi radians, correct? Can I reduce? What? I can divide by 2. So what else can I say? I can say 180 degrees is the same as pi radians. Now, I would use this conversion. Levi, you're driving me nuts today. Stop whatever you're doing. Okay, radians is on the bottom, correct? So that would be if I gave you a radians and I wanted it in degrees, because then the radians would cancel, correct? I would put a degree on the bottom if I wanted what? Degrees to cancel, be left with radians, correct? So there is a formula, little memorization tactic to convert from degrees to radians. You use Dr. Pot. Degrees to radians, pi's on top. Radians, degrees, pi's on bottom. But if you just use unit cancellation, you don't need a formula. Okay? So let's look here. It says convert from degrees to radians. So I want degrees to get the heck out of my life, and I want radians to stay. Yes? So am I going to multiply by pi radians over 180 degrees or 180 degrees over pi radians? Because I need the degree symbol to go away. I know that I'm going to have to put the 180 degrees on the bottom, which means that's going to cancel, right? Do we agree? And that's the same as pi rads. Now the cool thing about radians and sad thing about radians is you can write radians behind it to say it's radian. You can put rads behind it to say it's a radian, or you can put nothing and it is radian. So that's cool. I don't have to write anything to make it a radian, but then the radian doesn't cancel off. It's not noticeable. Yes? Or also the error happens and you guys forget degrees and you forgot them last year and your teacher was like, oh, they meant a degree. That doesn't work this year. You forget degrees, it's a radian. You know what I'm saying? So you have to remember that degree symbol. Okay. So if I want this to reduce, I'm going to get 315 pi over 180 rads. Now, okay, so this reduces to 7 pi over 4. And I can just leave it like this. I don't need to write radians. I don't need to write rads. I could. Now this is the catch. Listening? If it's a numeric response, it can be asked in the form A pi over B, something like that. What's the value of A, B, respectively? Well, then you would say 7/4, right? Or they can ask it, and this is where you actually do worse than. If I ask for it to the nearest 10th, people will go divide the 7 by the 4 and then just give me that answer. But the nearest 10th is the actual answer to that answer. So what would I have to do? 7 pi divided by 4. Because I want that answer to the 10th, which is what? Which, yeah, 7 pi divided by 4. 5.5. Then that would be the answer I want. 99% of the time they want exact values. Exact values are not decimals, okay? The moment you round, it is not exact. Everyone listening, pencils down in your brains. Okay, exact values are usually done incorrectly. Exact values are crazy, labeled really well. They are exact values. I know. That definition is crazy. So when you give me like 7.69347779 and you go 7.7, is that an exact value? No, that's a rounded value. That's the opposite of exact. Exact is you gave me exactly what the whole answer is. Yes? So what if the answer is 0.75? Is that actually an exact value? Yeah. 0.75 is exact. It terminates. It stops. It's the exact value of what the answer is. It's exact. So some people think, okay, decimals aren't exact. Decimals can be exact as long as they terminate. Correct? So 3/4 or 0.75 equally as exact as each other because they stop. But at the moment you round, that is actually not an exact value. So that's why when you put stuff into the quadratic formula and you get like x equals -2 plus or minus √3, and you guys turn it into a decimal after, and I asked for exact, you actually lose marks. Because it was exact, and now you ruined it. You made it rounded. You understand? So the quadratic formula reduce is an exact value. But if you turn that into a terminating decimal from a repeating or non-terminating decimal, like you make it stop, round to near 10 or 100, that is not. And, just so you know, putting ... behind it is not exact. Okay? It has to terminate. People are like, but I put ... No. Okay, so I want you guys to try B, and using the same reasoning, I want to see if you can do A and B. Remember I told you that if you guys can do stuff without me teaching it, that's pretty cool. So you kind of have been given a good glimpse. Let's see if you can work through it. There's a little hint. We're testing it out. What if you got something wrong? It's theirs. You're trying it out on your own. Better that you try it than you just watch me and be like, oh yeah, that's cool. Okay. Sometimes you just have to watch. Sometimes you can try on your own. So, we have a degree symbol that we need to cancel. So we're going to go work out as a question. That would be smart. Mrs. Lepp would say, stop doing that, Mrs. Lepp. That's dumb. You have to rewrite the question, right? So in this, it's just like a part of a question. We could get away with it. But on a test, we always rewrite what we're working with, right? We don't want to work under it. Remember I told you guys that when you're in a sentence, sometimes the equation comes out on the far right, and then you guys work down the far right, and you're like, there wasn't enough room. Or you're like arrowing back 70 times. No, don't do that. Rewrite it on the far left and make it sequentially neat. People will mark you nicer if it's neat. It's like, oh, look at this child. So neat. So nice. I like it. Okay? I don't mean the neatest thing in the world. I mean like you actually, I can follow what you're doing. Okay. So we have pi over 180 degrees. The degree symbols cancel. The zeros cancel. And I'm left with 7 pi over 18. All right. Now we're converting from this to radians. We know it's radians. Everyone paying attention? So, if this is radians, we can put rads if it helps you out for your conversion. Okay? Then we know we need a degree symbol, so we're going to go 180 degrees over pi, rads. If we so choose, you don't have to write it if you realize that the degree symbol stays. The pi's actually cancel. And what's negative 7 times 180 divided by 3? Negative 420. Because the 180 divided by 3 would turn to a 60. Okay, don't forget your degree symbol. Check if it's there. Don't forget your negative sign. Yes? Okay, the next one does not have a pi in it. no big deal. But the pi's just don't cancel off. Like this one, the pi's canceled, and I had just whole numbers that I could work with, correct? Not a big deal. It's still radians. I'm still going to multiply by 180 degrees over pi. The catch here, though, is that I have to divide by the pi. So you go negative 1.4 times 180 divided by pi. It just doesn't cancel off. Bless you. So negative 1.4 is negative 80.2 degrees. Okay? We are bypassing 4 for a second here. We come back to it later. It's like number 4 is literally this first. So if you don't know that we have lots of trig, your formula sheet gives it away. The entire right-hand side of it is trig. Okay? That top formula of zeta equals A over R is used in this number 4 example. We just do it later. It's not a big deal. But it is like a standalone little lesson. So we're going to touch that later because it's a Friday and I don't want to talk about that right now. So coterminal angles at the bottom are angles with the same terminal arm. So they terminate on the same arm. We talked about this, right? 120 and negative 240 terminated on the same arm. They would be coterminal. They terminate on the same arm. Principal angles are the smallest positive rotational angle coterminal with a given angle. So principal angles fall between 0 and 360, or 0 and 2 pi. That's your principal angle. So sometimes I can give you an angle that's bigger than 360, but then you're going to have to subtract 360 off it to get a coterminal that actually lands between 0 and 360 if I ask for a principal angle. Okay? And your reference angles are the acute angles between the terminal arm and the x-axis. I call them the bow tie angles. Do not write that on a diploma. No one would have a clue what you're talking about because it's just something I made up. So what does the bow tie angles mean? It means if my arm terminates here, this would be my reference angle. If my arm terminates here, this would be my reference angle. If it terminates here, this would be my reference angle. If it terminates in quadrant 4, this would be my reference angle. Those little blue things make a bow tie. You're welcome. So a lot of people want to state the reference angles between that terminal arm and the y-axis would almost make like an hourglass, okay? That never happens. They only ask for the reference angles, the ones between the terminal arm and the x-axis, so it's bow tie. Never going to flip over. Or use these definitions. All right. Everyone good? All right. So I want you to sketch all of these. Right now, radians makes probably no sense to you. Use pencil, please. But if radians makes no sense to you, what could you do to this? Change it to degrees and then draw it. The catch is when you draw it in degrees, though, you still need to label your axes in radians, and you still need to label the actual angle in radians. So I'm going to just go over this one first. Can everyone look at C for a second? I'm going to multiply by 180 degrees over pi. The pi's are going to cancel. I'm going to get negative 360 over 3, which is negative 120 degrees. Do you agree? I cannot write degrees around this thing, because the question was given to me in radians. I have to still do it in radians. Can I use the degrees to help me draw it? Yes, but the actual thing needs to be written in radians. So just so you know, the only thing that's the same, it's like temperature. You know, temperature, Fahrenheit and Celsius is only the same as 0. Radians and degrees is the only same thing there. It's the same as 0. So this would be 0. 90 degrees is negative pi over 2. 180 is negative pi. 270 is negative 3 pi over 2. And you will have these memorized within no time. And negative 360 is negative 2 pi. Now I know this needs to fall at negative 120, correct? So that's 30 past this negative 90. Do we agree? 30 past the negative 90. So I still draw my initial. I still draw my terminal. I still draw my arrow. Oh, it changed to blue now. Good job, marker. And then I need to not put negative 120 degrees here. What do I need to put here? Negative 2 pi over 3. Because the question was in radians. You can convert to degrees because you like them better, but you don't get to answer the question in degrees. Okay? That makes sense? Question still has to be all in radians. And your radian measure, like that 90 pi, 3 pi over 2, that's literally just converting them, but you will just end up memorizing those anyways. Okay? Just try and draw them out. So 60, we have 0. Come on. We have 0, we have 90, we have 180, we have 270, we have 360. I'm labeling them accordingly because it is a positive degree angle. I need an initial. I need a rotation. I need 60. I label it 60 degrees. 5 pi over 3. If you so choose, you could convert because right now it means nothing to you. So, what's 5 times 180 divided by 3? 300? Yeah. I just do 180 divided by 3, 60. 60 times 5 is 300. So here's my. Okay. So, I'm going to label it 0, 90 degrees, 180 degrees, 200. No, that would be silly. That's why I didn't actually do it. What are we doing? 0. Pi over 2 is 90 in radians. Pi. 3 pi over 2, 2 pi. Okay, we have our rotation. We have our initial. We're going to go past 90, past 180, up to 270, and then 30 more. Put our arrow on the end to show that we're going counterclockwise, which means positive, and we label it 5 pi over 3. There is nowhere on here that shows that I converted it to degrees other than beside, correct? You don't get to write degrees on it. Well, you do if you want no marks, but you know, options. I choose not that one, but we all get options. Okay. Weird. 300. Oh my goodness, it's the same. Okay. 0. I don't know. A lot of people don't know this. 90. 180. 270. 360. Rotate, initial arm. So we go past to that 30 mark again. Arrow. This time we get to write 300. All right. Now we have 135, but it's negative, so we label our axes in that way. So we go 0, negative 90, negative 180, negative 270, negative 360, initial, 45 past. So we're going to go negative 135. All right, I wanted to see what you guys would do with 750 without me telling you. So let's see. It's going to look more like a corkscrew. So, technically we would have 0, 90, 180, 270, 360, 450, 540, 630, 720, and how much past 720? 30. So we start here, initial. Make sure you have that initial arm. Go 90, 180, 270, 360, 450, 540, 630, 720, and 30 more. Yeah?